Welcome back, students, for the data analytics video lecture 8, which is continuation of the previous lecture where we started with the FM algorithm, and we'll be continuing it in detail in this video lecture. So what is FM algorithm? Flageolet margin algorithm. So for data cleaning, there are multiple techniques. But before cleaning the data, it is necessary to know that how much of amount of data which is present in the data set is actually useful. We have to find out how much is useful. So before removing the duplicate data from the data stream or the database, stream data or a database, it is necessary that we have to have a knowledge of how much of unique data, distinct data which is present in our data set. So what is the way to do is we go for hashing the elements of the universal set using a FM algorithm. So this is the purpose of a flageolet margin algorithm. So the pseudocode for that FM algorithm is step-by-step solution. It is used to maintain a count of distinct values seen so far given a large number of values. So you select a hash function h. So each element in the set is mapped to a string to at least log 2n bits, and each element x, r of x is equal to length of the trailing zeros in h of x, where h of x is the hash function, and r will become the maximum of r of x, which implies my distinct elements will be equal to 2 times the value of capital R. So this is the Python code. Like I have a stream, I have multiple values in it. So I'm going to print it, import the required things. We are searching throughout the string and we are calculating using the hash function. This is the usual widely used hash function, and we know this is a slicing operator. And then we start to check it and put all the distinct values into separate value. And what is the comparison of FM algorithm with the conventional algorithm, which was discussed in the previous video lecture? So again, I am repeating it. See, suppose we are using a brute force algorithm and we have suppose 8 elements in our array, and if we assume 20 bytes of data, then we'll have 8 into 20 as 160 bytes of memory to run the conventional algorithm. But for the same array, if we are going to use FM algorithm, then 2 bytes is going to remain the same, but for running the whole program, it will take only half of the memory which is used in the conventional algorithm. So half of 8 is 4, so we'll use only 80 bytes. Okay. So if m is the number of unique elements, then if my value of m is very small, then we can go out with brute force approach. But in today's data, which is a big data, which is a streaming data, a data stream, we get to have large data sets. So m is really going to become very large. So a lot of space is required, and the compiler may not let us run the algorithm in some cases also. So this is a scenario where our flageolet margin algorithm can be really used. This is a comparison between the conventional algorithm and the FM algorithm. So what are the applications of FM algorithm? It can be used in database query optimizations, big data analytics, spectrum sensing and cognitive radio sensor networks, network topology, internet routing. And next algorithm is going to be the randomized algorithm. Before seeing the algorithm, let us know why we are going for randomized approach. So the biggest problem that we have is how to save space without having to store all unique elements. I don't want to save all the unique elements because I want to save space. Okay, so I have billions of data. We don't want exactly, that we are not worried with the exact count to every single digit, right? So what we go for, it's enough that if I have an approximation within a reasonable margin of error is totally fine. See, our data is too big. We don't want a very specific data. We will be satisfied if we get an approximation, a nearly correct answer within a reasonable margin. So this is the main idea why we are going for an approach which is called as randomized approach. It is giving us an approximation. Here we'll approximate the number of distinct elements in a stream. Say suppose we have 1 billion entries in our stream. We don't want to be very specific. If it's enough if we can get a range of that value, a value which is almost very close to the exact value. So that is the purpose of randomized algorithm. So this is a very short, simple algorithm for randomized algorithm. So a function called estimate which takes in an array. We will use a hash function h, and every element in the array whose index starts from 0 to 1 will be accessed. Let the initial value of the value be infinite. I am accessing every element in my array. Find out for every element in the array, apply the hash function, compare it with the older value. If between these two values, calculate the minimum, and that becomes the new value for the val. So we repeat this, and finally the value to be returned is 1 by value minus 1. So this is a problem based on the previous algorithm, a sample program which I leave it to you to work out in a paper individually using your own time. Thank you.